Hi everyone, this is Kevanshu from ECD section. So today I want to discuss about the life of tube guy and its subject underlying pulse circuits as a tech talk concept. So coming to the introduction, we are going to discuss about the vacuum tubes and discovery of vacuum tubes and the person who biography of a person who worked on this vacuum tube in his life. So, coming to the tubes in the 21st century, many audiophiles claim vacuum tubes amplify music better than the transistor. So, these are also used as amplifiers, and this high-end Model 1 amplifiers collectively weighing 212 pounds. Here you can see the diagram of uh, a vacuum tube, which weighs 212 pounds, but designed by legendary audio engineer Mark Levinson. In the right side picture, you can see the tube diagram, which having the parts like glass envelope, plate which is anode, and cathode and grid. So these are the present 21st century tubes we are using. So coming to the detailed explanation of the circuit diagram, like grid or electron controls the electric current or flow of electron between anode and cathode. So the free electrons that are emitted by the cathode are attracted towards the anode or plate. These free electrons carry the electric current while moving from cathode to anode. And when this is based on directly heated and indirectly heated cathode. So in the thermonic tubes, the cathode is heated electrically to a desired temperature to emit the free electrons from the metal surface. This can be done in two ways, by directly heating the cathode or indirectly heating the cathode. So first let us know about the vacuum electronic devices and vacuum devices. Initially, vacuum electronics. In vacuum electronic device, these are the electronic devices in which electrons do not collide with other particles or in which the collision probability is very small in the transport process can be theoretically regarded as vacuum electronic devices. These vacuum devices stored caught during the Cold War, advanced particle physics, treated cancer patients, and made the weightless sound good. So these are the applications where we use the vacuum electronics and vacuum devices, vacuum tubes. So here below you can see the words of a great Carter M. Armstrong. Like if he said that if you told me I will spend my career working on a vacuum tube hours, I would have said, no way, that's crazy. Is said by Mr. Carter M. Armstrong. So he's the one person who has spent the last 40 years of life on working on vacuum devices. He's the vice president of engineering at electronic devices division of L3 communication. He received his undergraduate degree in physics at Rutgers University and his PhD in non-neutral plasma physics at the University of Merida. So this is the picture of a Dr. M. Carson M. Armstrong. So, after a postdoctorate in the laser plasma group at the Naval Research Laboratory, studying hot electron generation in laser produced plasmas, Carton joined the physics faculty at North Carolina State University, where he studied non-neutral plasma stability, relativistic electron beam propagation, and collective ion acceleration. After returning to the NRL as a head of the fast wave device section, Carter led exploratory research and development on novel fast wave coherent radiation sources, including gyroclystrons, harmonic gynopentrons, and ubitrons. So it was during this period that Carter rediscovered the vacuum device roots of non-neutral plasmas and became a tuber. So these were the works done by the uh, Carter, which gave his name as a tuber, because he spent his 40 years of life working on only sections of vacuum device. So it would be later while working in industry, first at the Northrop Defensive System Division, now known as a Northrop Grumman, then later at lit and electronic devices now known as electric communication. That's the fun and challenge of working on slow wave devices like TWTs, like means both hot and cold cathode various klystrons and microwave power modules known as MPMs and would command its carrier. So these were the section he mainly worked. Like Carter first became involved with the MPM, means microwave micro power module, and which is an ultra high power density RF amplifier marrying the solid state. Vacuum electronics and power electronic technologies at Northrop, where he oversaw the development of high efficiency and wideband vacuum power booster TWs. So here you can see the below picture as a RF amplifier uh, where he worked. So his environment with micro power modular technology only increased with his subsequent move to L3 electron device, where he has led the successful extension of approach into millimeter wave range. It was at L3 electronic devices that Carter established an engineering intern program to bring in the next generation of vacuum electronics, mechanical design, and the power electronic engineering. Working closely with the vacuum electronics research program at the University of Michigan, Urban and University of Wisconsin, the intern program at L3 has been nothing less than an outstanding success, serving to usher a new generation of bright and energetic engineers into the field. So he's working like many persons to be as engineers in the vacuum device section. So Carter has served as a numerous government advisory committees, including the DoD Lord Advisory Group of Electronic Devices, which is aged, and it was while an aged that Carter co-chaired a review on compact terahertz sources. He published a feature article on the technical pursuit in the 2012 September issue of IEEE Spectrum, entitled as The Truth About the Terahertz. The paper was selected as a finalist in the technology area of 2013 Jesse H. Neal National Business Journalism Award. Carter has been an adjunct professor in the EC department at the University of Wisconsin since 1990. He was elected as a fellow of IEEE in 2013. And finally, for his excellence in vacuum electronics in 2013, he was awarded with the Pitts. John R. Pitts. So, thank you very much. I think you have got some idea about the vacuum tubes and the life of a Carter M. Armstrong, who got the name as a tube guy for his work on vacuum electronics, vacuum electronic devices, and vacuum tubes. So, thank you.